Welcome back to the course Make It Work React Hooks by Fang. This is the 7th video in the series, useRef to access DOM.
In the past video, we have built a Google search-like box to search through a list of Pokemons fetched over internet. So we want to add a small touch-up feature. After we type in some search string, we'd like to have a button nearby to clear the search string for us. It's normally displayed using a close symbol. For the simplicity here, we'll just use a button. So let's go to the file that we implement the search and okay, let's add a button. Say the label clear. Okay, cool. And let's add some spacing in between so that they're not stick together. And in order to get it working, we need a button event handler on clear. So when we click the clear button, it will remove the search string. So it's working. After we add the button, we notice it can clear the input field perfectly. However, we also noticed a small issue, which is we can't go straight to type the next search string in the search box. Instead, we need to first use the mouse to click the input before we can type again. This can be quite annoying if I were the user. So let's retrospect a bit. Initially, the focus is on the search box. The second we click the clear button, the focus is shifted to the button. And afterwards, the search box isn't receiving keyboard input anymore. So can we gain the focus of the search input again? Yes, you can. But this time has to be a manual process because we don't expect the user to click on it. Let's first take a look at how we can do this without a React using a few JavaScript lines. So in the old days, we can always do document to get element by ID. Suppose the ID of the element is called a search, and suppose we find it, we can just do invoke the focus method on it. And of course, we need to find this element and give it ID search. So this way we can find it. Okay, let's give a shot. Oh, yeah, we can go straight to type now. So it actually worked. Basically, we use a DOM method, get element by ID, to find an element with a matched ID. When found, the focus method can then be invoked upon it. Here, the question mark is the TypeScript syntax to skip the following statement if input is a non-object. Okay, it worked. However, there is an issue associated with this old school approach. That is, we don't actually know when this element exists. For instance, it might be too early or too late before the element is mounted or after the element is dismounted. In order to address this, React provides us a relatively safer and a cleaner way to achieve that, which is through a hook, useRef. All right, let's take a look at it together. Okay, let's try to use the useRef reference here from the React. And now we can come here and create a ref. Use this useRef hook. Let's give element type for this input box. And we can delete the ID because we're not using that approach, and set the ref equals to ref. All right, and change the ref dot current and focus. And let's give a shot. And clear. And we can continue typing. That's great. So with the usage of the ref, we now don't have to look for the element when we need to. Instead, we wire it with the element via the ref attribute. And then we can invoke any DOM method of this element through ref.current. Now we have seen this example. Let's take a look at the usage of this useRef hook in more details. It takes one input parameter, initial value, and returns an object, ref. A ref is a plain object containing a property called current. When a ref is wired with any React element, its current property will point to the DOM element upon the amount of the element, and it will be set empty upon the dismount of the element. The timing of mount and dismount becomes transparent to the developer, since React manages the life cycle of the component. Note, we are discussing two types of elements here. Before the usage of React, we only have the DOM element, which is a node directly associated with the HTML DOM. And this is also where the ref points to. Another element is the React element, which is the one returned from any React component function, such as return div hello world. This tells us React element is an extra layer applied on top of the DOM element. Since a ref can point to the mounted element, it can be naturally used to indicate whether the component has been mounted or not. Thus help us to solve some interesting problems. One of them is the memory leak. Let's take a look at the fetch function we wrote in our earlier videos. One interesting fact is that any async function carries a potential memory leak inside React. This statement sounds a bit scary, but the good news is that it's not easy to hit the memory leak. I wouldn't say it's rare, but practically you need to hit one condition to see this happen. The condition is to have async action finishes after the component issuing the async action gets dismounted. Normally, we don't dismount the component very often, but sometimes when that happens too abruptly, especially before the async inside finishes, we get this memory leak bug. Here's an example set up in the code pen to demonstrate to you. We have a typical component called title, where inside it fetches from Google, and when the fetch finishes, it sets the text state. This is quite similar to what we have in the Pokemon API fetch case. Under this component, we create a parent app component that will delete the title component when we hit a button. Here, the flag state is wired with a button to make the dismount happen. Okay, now with this simple setup, we can try it out. All right, let's refresh the page. Before we finish, let's click the button. Okay, now we see the warning, which says can perform a React state update and an unmounted component. And this is exactly the bug we were talking about. And it also says it indicates a memory leak in your application, and it also tells you how you might possibly fix it. If we trace back, we can find out the exact line that it complains is the set text statement. But why exactly? Keep in mind, when we hit the button, the title component gets dismounted. You can just imagine it's deleted and moved to a trash can. In that case, everything which was under this component, for example, states as well as methods, should be all gone. That's why now if you invoke setState, setText, it's like asking it to go to trash can and invoke it. In the old days, if you do that, your computer could give you a famous blue screen. Wow. Luckily, with the modern framework like React, we don't get a blue screen when that happens. Even better, React will detect the situation at runtime and output a warning sign on the screen. So how do we fix it, you might ask? There are quite a few different ways. Here, we'll show you a quick way by using the ref we just learned. Since we know the ref can tell us whether the component is mounted, we can use it to help us to bypass the problematic statement if needed. Let's go to another code pen with the solution implemented. Let's see it in action first. Yes, we don't see the warning anymore. Now let's see the solution. We can see here is that we installed a ref and named it mounted ref. We initially assigned it a Boolean value true. And during the cleanup of the use effect, which is fired when the component dismounts, we then set the flag to be false. This is why we named the ref mounted ref. Now we have the indicator. We can just go to the success handler of the async call and ask it to skip all statements when we find out the component is already dismounted. Nice. This solution is easy to be implemented in your own work, and you most likely will step upon this memory leak issue, especially when you deal with moving from one page to another page, or animations where components are free to mount and dismount frequently. We have used the useRef in the previous two examples, so now we can try to answer the question, what is a React Ref anyway? In a plain language, it creates a reference pointing to some memory space. The memory space in our first focus example is a DOM element, and in our second memory leak example is a Boolean. There's no specification of what the ref can point to. For this reason, the definition of a React Ref has been expanded into holding an external memory space outside of React. Either it's a DOM element, a third-party service element, or anything global you don't want the React to react. The statement that you don't want React to react is kind of interesting. What does that mean? React wants to react on the change of state so that it can orchestrate all the render of the components for us. But in this case, have you noticed, even when we change what the ref points to, it does not trigger anything inside React. Literally, the reason why it does not trigger anything is because the ref.current assignment statement. When you write to the ref.current, it only assigns a new value to the current property of the ref object. There's no hidden lines behind the scene. If we are not entirely convinced this fact, we can demonstrate it with a quick example. And let's create a new file under the features of a Pokemon. Let's call it a ref button this time. And we want to create a new component to demonstrate the ref usage. So let's name it ref button equals to the component syntax. And inside, we're going to first create a ref. This time, we're going to use a number for the demonstration purpose. So it starts with a 0. And we're going to have a click event. And upon the click, we want to increment this number using the ref.current. And also, for the sake of simplicity, we want to have a variable to point exactly to this ref.current. All right. And so now let's display something. We're going to have a button, and the label of the button will be exactly this count. And the click event will be wired with the event we just created. All right, very simple component. And let's export it. Cool. There is some missing useRef. Yeah, normally we would write use state for the purpose of incrementing a count state. But here we want a demonstration to you that what the major difference between the use state and the useRef. So here we go. We just created, and now let's find a place that we can add this button ref. So let's pick app.tsx. So this probably is the easy way. So if we put it here, we can just see the button on the first part of the page. Okay. All right, and we need to import it from the folder features Pokemon, features ref button. Oh, see, we see the button there. It's pretty big. All right, we try to click on it. And surprisingly, we don't see the count moving to 1 and 2 and 3 as we expected. That's kind of interesting because if we were using useState, we would expect this to increment as we click. So let's open the console log and maybe add a console log message here just to see what really happens for the ref dial current, because we don't see it displayed. So what's going on? All right, with this console log, and let's click to 1, 2, 3. Yeah, so seems like the ref dial current is incrementing, but there's no associated rendering. So it's always displayed a 0 no matter how many times you click the button. So this is exactly the main difference between a useState hook and a useRef hook. The useRef hook doesn't have a set state method to invoke any re-render. Instead, it allows you to set the current property directly. So this further concludes that the logic under the ref works as it's designed, except it detached the logic from the React control. Because of that, now we can do things behind the React. In case you need to set up any process parallel to React, that'll be a good usage of it. All right, we learned a new hook, useRef, in this video. It's powerful to operate DOM element or hidden things from React. Thanks for watching.